In last year, May 2023, the World Economic Forum released a statement on deepfakes, and actually found the TLDR under the title a bit amusing. So one of the bullets was, experts predict that by 2026, 90% of all online content will be synthetically generated, which is terrible. And the next line is, we need to develop detection methods for this. Uh, if 90% of online content is synthetically generated, I can give you a detector with a whopping 90% accuracy in detecting synthetically generated content today. All it needs to do is just say that's synthetically generated. It's going to be correct 90% of the time. So deepfakes are not really the problem. You can't say that 90% of everything, I mean, as cynical as you want to be, you can't say that 90% of all online content is wrong, and I need to be able to tease out the remaining 10% somehow.
Hello, hello, Tal Hassner. Thank you for being with me. The Human Zero Day, a series which I've grown to love so much, because over the next short while, we'll be speaking about something that I became increasingly passionate about. And I think everybody that's sort of here with us right now are getting really interested in. Thank you so much for being with me.
Thank you for having me.
So, Tal, it's hard to introduce your background because your background is quite incredible, not just because you're a scientist by training, right, with a PhD in applied mathematics and computer science from Weizmann Institute, but you've applied yourself as a research scientist in numerous different capacities at some of the obviously most successful companies in the world. And you've also taken part in building a lot of core foundational systems which we rely on to act on our in our digital landscape, and that speaks to our digital identities and biometrics, and growing with the field also in the context of the way that generative AI is impacting digital identities. And now, most recently, congratulations on being in stealth at a startup. And so you're really taking the whole system end to end. And but seriously, thank you very much for taking time to be here.
That's my pleasure. Thank you for inviting me.
Tal, how did you? And I forgot to mention, small note that you also sit on chairs of numerous different organizations, and you effectively help review some of the most cutting edge literature in the computer vision space. But Tal, what got you into this world of computer vision and specifically maybe even identities? How did you find yourself there?
I was actually thinking about that the other day. Funnily enough, my the decision to go into computer vision, um, I made that decision before computer vision was popular. At the time, it was almost theoretical, um, and I made it, funnily enough, because of a deep fake, or at least what we would maybe consider a deep fake today. This was back when deep fakes was not a term anybody was familiar with. Um,
Do you remember what it was?
oh yeah, I remember exactly that. So I just started my graduate my graduate studies, and when you do that at Weizmann, the first few weeks you get to, as a student, you sample these different courses, trying to get the lay of the land, trying to see who you connect with, what sort of professors you resonate with. And there's a lot of interesting stuff, theoretical computer science, complexity, different types of mathematics. But it was all sort of, maybe, I don't want to use that word, but a little dry. But and then I was sitting in very tired at the end of the school day, in a classroom, waiting for the beginning of a new lesson. And this young professor, very energetic, very charismatic. This was back in the day when if you wanted to show a movie, you had to like push in a cart, like a big television with a VCR underneath. So she was pushing that in front of the classroom and she was pressing play. And she was showing a video, black and white video, grainy, of just herself. No words, it's sort of a mic drop minute of herself walking through a computer vision lab. Also a lab with computer people sitting, tables, laptop, no, screens. It was just the camera tracking her. And then she paused it and said, and now I ran some processing. This is computer vision. This is what computer vision can do. And you press play again. It took me a few seconds to realize the difference between the first video and the second video because it looked almost the same. Second video just didn't have her in it. So she was gone from the video, including her reflections, including she sort of made herself disappear. In our neck of the woods, this professor Michal Irani from Weizmann Institute, and that was called Disappearing Michal video. And I was looking at that and thinking, oh, that, I want to do that. That looks really, really cool. So that actually started my journey into computer vision. Identity is something that happened a while later.
Wow. Okay. And when was this grad? I don't want to date you, but I have it in front of me, and I do think this is important because deepfakes are often associated with a 2017 Reddit
No,
thread.
no. It was actually if you want to associate it with a 17 number, I think the right 17 number is 1917, which I think is when the um, I think it was called the Kakengi fairies story came out. Uh, but to your question, this was in 1997 or 8, I guess.
Incredible.
Um, but
Incredible.
yeah, so people have been manipulating media long, long, long before deepfakes. Ever since people were able to capture media, it's been manipulated, and for any of the reasons that you're seeing, for all the reasons that you're seeing today.
Absolutely. Wow. And then obviously the world over the last 2 years took many existing problems and exacerbated them. Also took so many existing problems and started to help solve them, which is also amazing. And tell me a little bit about your journey in your actual implementation of your technical skills in the real world, in real world scenarios, because it feels that a lot of the work that you did, especially recently, I guess from about 2018 or so, has been really in cornerstone technologies that are now servicing many other technologies in the context of facial recognition and identities.
So, but I don't know if there's a particular switch or change or milestone moment that I can point at. This was a gradual progression. I started working on problems related to face recognition seriously at about 2000 and 2008. This was with Lior Wolf from Tel Aviv University. Uh, and at the time, uh, um, cutting edge new benchmark, a new problem came out for computer vision, which was very intriguing for us at least. This was the label Faces in the Wild benchmark, which anybody that's been doing face recognition in the last decade knows very well. And it was revolutionary. I don't know if people today understand just how revolutionary it was. Um, Up until that point, there were already a lot of face recognition work being done, and there were studies, federally funded studies, that were showing that computers were already doing better than people in recognizing faces. But all those studies used photos of people which were obtained under what I call biometric circumstances or controlled or constrained circumstances. So this would be a person standing in front of a computer or in front of a camera, and wanting it to recognize them. They're participating with the recognition system. Um, they take their glasses off, they put on a stern face, and they look straight at the camera. And in those use cases, computers were already doing better than humans in 2006, 7. But then Label Faces in the Wild came out. Label Faces in the Wild was the first big benchmark, as far as I know, at least, to 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 challenge computer vision systems with photos of faces that were in the wild. So these are photos that were taken in for media purposes, sports, publicity, whatever. These were scraped photos, and none of the methods that were performing the methods that were performing well, though the state of the art methods that were beating humans at the time, they collapsed. They just couldn't handle the variability, the appearance variability. Um, and that's when we started looking at this. This was the 2008 was the first time that we got involved in this. This is the first workshop on Able Faces in the Wild. Um, we got very good results on it at that time, and from then on it was just a progression from one paper to the next, from one system to the next. In 2018, AWS reached out, and I think the way they described it is, we want to commoditize face recognition, and yeah, that was the switch from academia to from doing this for papers to doing this in for a product.
And what was that like for you, transitioning from very deep technical research to doing that same thing, but now needing to productize it at the end and having customers in mind?
Um, so first of all, there's for someone who's been in academia for many years, the move from academia to industry is not always easy. It's a different environment, but this is on the call it
Right.
organizational aspect of it, which looks different. One of the things that you notice immediately is that in a lab, you're typically a one-stop shop. It's just you. If there's no one's going to collect your data for you, there's no one going to vet anything. This is just you. When you're working in an organization, certainly AWS or later Facebook, um, one of the organizational changes, one of the psychological changes that you need to get accustomed to is, you have this massive support around you that can power multiply. Um, and this is before we start talking about the resources that you have in these places, the data, the storage, the processing power, things that in academia would be science fiction in many cases. So yeah, it was a big difference.
It sounds like also just a big playground for experimentation and research, especially not just the financial side, but the actual ability to scale with the data that potentially only this organization would have. Transitioning the conversation to a little bit to your work at Meta, I'm sure that you're seeing similar impact of application of research, but in a totally different world, right?
So the products in AWS were products that the main product was a face recognition a service that people can use. At
The
Meta, this
famous
is the
AWS recognition.
yes. At Meta, this was um, the face recognition. The face recognition product at the time, it was a tag suggestion product,
I use that product
these
quite a bit myself. Yeah.
and the OCR. And both of them, for very different reasons, both of them, the idea that this is something that's running. I mean, if you think OCR, optical character recognition, this is taking us a little bit away from biometrics, but it's just an easy example uh, so we're talking about a system that needs to be able to detect and recognize text in any language that Facebook has users understanding and reading. And it has to be scalable, and it has to be fair, or at least equitable. So you need to be able to process or to deliver the same sort of level of accuracy for languages which have Latin character sets, as you do for thousands of pictograms in Chinese. Um, and then you have questions of where do you get the data, and then there's the questions of how do you do this responsibly, because there's regulations, and how do you maintain that, how do you do that efficiently. And we were my job was just to develop to be involved with the technology itself, with the OCR technology itself. But there's downstream use cases for OCR, which could be very, very influential from a societal perspective.
How so?
I don't want to talk about specific products at Facebook, but you can imagine the importance of being able to recognize text and images for
Mm-hmm.
various for various even safety applications.
Sure. Exactly. Absolutely. Well, Tal, I'd love to transition for a second to the world of the security aspect of the space, because it's the Human Zero Day. We're looking at also not just the technological advancements in the space, but also how these technological advancements are impacting the security vulnerabilities that we as humans have in our day to day. And this is relevant for both democracies, and as well as for organizations and enterprises, and our ability to do what your professor did in 1997 or 1998 today in a commoditized way. It's a pretty alarming one, but it's only one example where potentially we can misuse technology to trick and fool somebody to doing something they didn't mean to do. And in that case, for example, it's the use case of a deep fake impersonating somebody. In many other cases, it can be simpler social engineering techniques. But since this is you are coming from a very technical background, and you've actually had a chance to hands-on not just work but publish really cool papers, and I got to check out some of them myself. I'd love to hear a little bit about your experience in thinking through what are ways in which one may be able to keep up with what's happening on the generation front in the detection space.
It was hard to keep up with the generation from just in the generation space, let alone with the detection space um, in recent months. Um, so first of all, the problems, the risks with deepfakes. Again, these are not new by any stretch of this goes back long before there were computers doing deepfakes. There is maybe a difference in how accessible these tools are today, the quality of their output, and maybe more importantly, though, and that's arguable, the channels through which they can be distributed. Um, so with all that, that maybe makes this problem bigger. But let's talk about the problem. Let's talk about what is the problem. Um, in last year, May 2023, the World Economic Forum released a statement on deepfakes, and I actually found the TLDR under the title a bit amusing. So one of the bullets was experts predict that by 2026, 90% of all online content will be synthetically generated, which is terrible. And the next line is we need to develop detection methods for this. Uh, if 90% of online content is synthetically generated, I can give you a detector with a whopping 90% accuracy in detecting synthetically generated content today. All it needs to do is just say that's synthetically generated. It's going to be correct 90% of the time. So deepfakes are not really the problem. You can't say that 90% of everything, I mean, as cynical as you want to be, you can't say that 90% of all online content is wrong and I need to be able to tease out the remaining 10% somehow. Um, so the simple question of is this media item synthetically generated, yes or no? Media item could be image, video, audio. By the way, even text is a in some sense a deep fake. I'm looking at you, ChatGPT and Claude. Those are also deep fakes. Those are also synthetically generated. And everything I'm saying, most of what I'm saying relates to those as well. Um, if just looking at the question of looking at one on a media item like that and saying, is it yes or no synthetically generated? Not really interesting. In a world where 90%, where everything is. So the actual questions that we're asking, the actual questions that I think are interesting to try and solve, like maybe broadly can be categorized under uh, three labels. One would be provenance methods, the other would be attribution methods, and the third, arguably the most important, is integrity methods. Um, and um, and so, when you're trying to solve these problems, those three categories are where you want to look for your solutions, depending on the product, depending on what you're trying to solve for. Just to maybe explain what these things are. Um,
Please,
so it's not just abstract.
please.
So provenance is tools, methods, technologies that allow you to trace the lineage of a media item back to its to verify, trace and verify the lineage of a media item back to its source. So think about maybe a painting by Renaissance artist being sold in an auction house today. When they sell it, they show the signature of the artist on the painting, and they show maybe documents that prove how it was, or that document how it was exchanged hands over the years, going all the way back to the source. That would be provenance, the ability to be able to show this is where this item came from, and this is why. And digital form that takes that looks like watermarks, and in that sense the artist's signature on the painting is a watermark. This is an artist's watermark on the painting. uh, it could be invisible watermarks. Invisible watermarks are tiny changes to the pixel values in an image which you wouldn't be able to tell happened, and you see the image before and after these changes were made, and you wouldn't be able to tell the difference. But a computer would be able to tell the difference and would know just by seeing those changes that this is a signature, an artist's signature, that this came from a particular source. There's other methods of doing provenance. Those are just two examples. Maybe the simplest form is just adding metadata, but that can be manipulated easily, so maybe not a very effective provenance technique. The second, which I've recently done some work in, is attribution. Going back to the artist, Renaissance artist example, let's say instead of auction house selling this and giving you documents, you discover in your attic rolled up parchment with an unfamiliar painting and with no signature. You take it to an expert, and the expert looks at the brush strokes and looks at the colors and the composition, and the expert says, "Well, based on all that, I can determine with 90% accuracy that this is this artist that did this work. This artist painted it." So you don't have that lineage, that tracing, but you do have that analysis that estimates where this came from. That would be attribution. Again, in digital form, that would mean looking at at an image and that you just downloaded, that was just posted online, and being able to say something about where it came from. So not just a yes or no question, but who or what generated or created that image. Um, this is not a new field. So in painting, of course, people have been doing this. There's been artists that have been art experts that have been doing this for a while. But you can do this, and by taking an actual photo and recognize the camera model that was taken on, and you can do this by taking a generated image and recognize the AI model that produced it. So that's the second type of problems, attribution. The third, again, arguably the most important for security, most important for societal impact, the most important if you want to try and solve these problems, I think, in my opinion, is integrity. Integrity means all the different technologies, all the different ways that you can take an image, analyze it, and ask about the content if it's okay, yes or no. Okay here means, is it violating laws? Is it, whether these are whatever laws, could be IP laws or it could be explicit material laws and so forth. Is it is it a picture of counterband? Is it a picture of hate speech or misinformation? Analyzing the image and trying to answer those questions. And the reason I think is important is if you have a photo of something horrible, that someone's spreading on the dark web, do you really care if it was a photo that was taken with a camera or a realistic photo that was generated? It is horrible one way or another, and you want to, that's what you want to try and protect against. The question of whether or not it was generated, who generated it, and why, all those are secondary, I think, to recognizing that there's a problem with this image, for however you want to define problem for your security application for your in your context.
This is fascinating. Tal, do you think that the way you're describing the effectively four solution spaces, right? So I heard provenance. Well, wait, I'll get there. So provenance, watermarking, integrity. Well, provenance, attribution, integrity, and then detection as a non solution.
Yeah, it's not really interesting. I mean, again, if you know that this is a bad image for, again, whatever reason, bad could be child pornography, or it could be just someone violating your IP and using your logo. It doesn't matter what you're looking for, but not that I'm equating those two. I'm just saying,
Of course, no,
depending
but
on
I'm,
what
I'm
you're
not, but my
defining for
question
you.
is, do you believe that is applicable? That this assessment is applicable to both the online misinformation, disinformation space, as well as the enterprise cybersecurity defensive systems. Is that would is the same your same assessment of solution spaces be equally applicable to both situations?
I think so. Yeah. Again, if it is bad, you're trying to recognize if the person you're talking to is not who they say they are. It doesn't mean that you care if it's AI or a
Mm.
very good impersonator.
So you say let's look at the verifying the identity or the device as the fundamental layer, and if it's from the verified source, or that's the main question or not, right? As
I
an
think
idea.
so.
Yeah.
Yes. The yes or no, is this fake? Um, we're very, very. I wouldn't be surprised if in the next few years there will be readily available and commonly used technologies that would make this conversation, for example, this exchange, for example, very, very natural, but without us actually being here, and it will still look real and be acceptable, and everybody will be fine with it. So
Yeah, I
just
think
detecting that,
Notebook LM did
yeah,
this with audio
exactly.
just recently, right?
Yeah, exactly.
Yeah.
So I don't really care if they're real or not real. In many use cases for notebook, I would want to hope that all use cases for notebook LM are legitimate. And you listening to it, and it sounds. So, do you really care if they're real or not?
Sure. Well, so Tal, I'm curious. You've been in this space for a while. You also did have a chance to work on detection technologies, and in the context of deepfakes. Even regardless of whether it's a real good solution to a from a business question, because that was the discussion we had now. I'm curious to hear your perspective technologically on this, because one of the big things we read every day and that CISOs are highly concerned with are this seems like a big arms race. We've seen the antivirus approach take place in Symantec and Norton in the year 2000 with malwares. Are we facing, you know, is this going to be just a replicating malware 2.0, or antivirus is going to keep up? How should we think about this technologically?
So again, going back to the three categories, then it's it's more a question of not necessarily a question of how can we keep up with the deep fakes. It's more a question of how can we keep up with particular types of media that we don't want being spread. Again,
Hmm.
regardless of whether or not they're faked. And by the way, fake does have an influence on, it does make those problems more challenging. I mean, you're seeing, I don't know if you saw them, I'm sure many have, these photos online where it looks like, I don't know, natural building with some trees and forest, but if you squint your eyes, you actually see a face or you actually see
Mm,
something. So that's already stop people are already starting to use that in order to spread some very troubling messages, and AI in that respect makes that easier. It's a lot easier to create an image like that with AI than it would staging it in real life. um, but that's an arm race between not between fake detection methods and fakers. That's an arm race between uh, uh, people who are trying people organizations who are trying to spread bad content. Again, your definition of bad, versus those that want to for whatever reason block this bad content. um, and that's a very old arms race that
sure.
has nothing to that hasn't again, generative AI makes things easier for the other side, and it makes it more challenging to detect those images. I mean, I was talking about OCR earlier. So in OCR, I don't want to give anyone any ideas, but but you obviously, if you have like a meme photo with a text clearly written in it, that is much easier to recognize that there's text in the image versus different ways that you can maybe make it harder for a computer to understand. Again, not giving anyone any ideas, but you could do that even before generative AI.
Right. That makes sense. I think I'm asking on the I had a I have now some experience in the world of detection. In fact, I've spent great time and energy understanding detection. By the way, not because I think it's the right solution, but because when approached with and challenged with this same notion of, can we check whether this person we're talking to in a business setting is real or not? Or is this the person we want to be talking to? The solutions in place for provenance, attribution, and integrity are just not there yet, right? There is infrastructure to be built for that, and there's great organizations like the C2PA, for example, which I very much appreciate the way that they're generating momentum, and so I'm looking still at this next year and a half, and I'm asking, well, if over the next year and a half, people are scared that they will be the next social engineered human in the context of hiring a North Korean spy for their HR team, or sending money when your CFO didn't ask you to send money, or you're the IT support for MGM Grand, and you're about to give away that VPN access to your colleague. I mean, then what can we do in this next year and a
I'm
half?
I don't want this to be understood as though I'm saying everything that you just said is not a problem. It is definitely a problem, and that problem is growing. And deepfakes are making that problem
Sure.
in many sense, or changing the way that. I mean, I give the example of those images where you squint, but with the example of someone calling you, and you think you're talking to the CEO of your company, but it's actually that problem also existed before. But before, you'd need to hire a very talented
Actor,
impersonator,
yes.
and now you can do. So it was a problem before. It was something that you needed to address before. Just now, there's more people that have more access to this, and so you need to evolve the solutions and evolve the technologies in place. But just asking, is this fake or not, is not necessarily how you solve how you solve that. Um, uh, you have more. I don't know if more, but you have KYC systems, for example, which can help you verify that someone is who they say they are. Maybe you need to install more. Not that I'm promoting anything, but maybe you need to install more KYC checkpoint, know your client or customer checkpoints to verify that the person that you're talking to is the right person. So that CEO CFO interaction, maybe that could be solved with better policies, internal policies on what the CFO needs to be doing rather than detection methods.
And I've
The
heard that is a very real practical notion amongst security professionals asking, well, if we had the right process in place, no deepfake could harm us, because even if they did get away with a deepfake, then the right process in the important workflows wouldn't let the bad things happen. Because nobody should take. We should exercise effectively a zero trust policy when it comes to perhaps
sensitive.
the sensitive in these informal interactions.
Um, Look, you gave the example of very apt example of the virus antivirus arms race. I know organizations where they have very strict policies on what you can or cannot do within the organization, so as not to expose the organization to viruses, regardless of whatever antivirus firewalls. Well, they have very strict policies. You cannot, for example, connect an external device via USB to any of the computers inside the network, for example. Um, that policy effectively, if followed, would effectively stop viruses from coming in. It's not a technological antivirus firewall solution. It's maybe a boring solution, but it's a very effective one. I don't think it's a one-stop shop. It's a one solution panacea
Exactly.
for anything, silver bullet for anything. I think in some cases it's enough to have a policy change. In others, you need to do something more subtle. Others, you may need KYC systems. And KYC is technology that you need to develop, and attribution, provenance, integrity method. These are all technologies that need to be developed. And under attribution, by the way, there's a lot of work in analyzing deepfakes. So this is not that I'm saying no, the solution, that's someone else's problem, solve it with policy. That's not my message. I'm saying it's more nuanced than just, is it fake, yes or no.
Absolutely. I completely agree with you. And Tal, we can. I have so many more questions to ask you, and so many more topics to talk about. And I really want to thank you for taking the time to be here with me.
My pleasure.
Obviously,
Thank you for
you
listening.
have you've been, well, effectively, you've been looking at the space for about 25 years. So I guess it makes sense that you have some very strong ideas and opinions about also how the world operates in the context of this. And going back, I think that most fundamentally, you're absolutely right. This is not a new problem, right? The problem of deep fakes or manipulated content is not new. As it pertains to human security, I think that what is new is potentially the level of accessibility and the rate of change. And so I think that potentially from a security perspective, many look at the threats and are saying, whoa, this is new. I haven't had an employee tell me that they spoke to a candidate which never existed. This is
The World Economic Forum statement from last year, one of the other findings is that in 2022, so we're talking about almost 3 years ago, 60% of cybersecurity experts were already reporting deepfake attacks, deepfake security attacks on their respective organizations. So that's before a Flux and Sora and the stuff that you have right now. So yeah, you're right.
absolutely. Tal, thank you so much. Really appreciate your time.
My pleasure.